In question 14, we're asked to write the equation in factored form of the rational graphs below. So here's the first graph I'm looking at. One of the things I'd like to put in here to help clarify a few ideas is that we have a vertical asymptote, at least one. I think I see another one as well. There's a vertical asymptote here at 2, and then there's also another vertical asymptote, again at a -3. So I wanted to add those to my graph to help provide some clarity in what I'm going to do with this. Because when we graph, or when we write the equations of our rational equations, on this top we want to look at the numerators. To create the numerator, we want to get the zeros of the function, and the zeros are also called the x-intercepts. When we create the denominator of this fraction, we want to make sure we have the zeros, or anything that makes it undefined. So these are the zeros of the denominator, and those are going to be your vertical asymptotes. So I'm going to start generating what I think should be the equation of this rational expression. So some of the things I'm looking for to create the numerator: where does our graph cross the x-axis, and how does it cross? Well, our graph is crossing at 0, and it's crossing as a line. It's simply crossing through, so it's x to the first. Then it's crossing at 4, and again, it's just crossing there. So when it's crossing at 4, the factor is x minus 4. The other things that help me build this equation, especially the denominator, are the location of the vertical asymptotes. So one vertical asymptote is at a -3, so that's an x plus 3 factor. Another vertical asymptote is at 2, so that is an x minus 2 for our vertical asymptote. I've got to use one more context clue here to see if I have this in the right place. My last context clue here is where this horizontal asymptote is located. And that horizontal asymptote appears to be at a +1. So if that's at a +1, it means that our ratios, it first of all means that the degree of our polynomial on the top and the bottom of our rational function has to be the same. So this is an x squared, so it's a second degree polynomial, and this x times x is x squared, so it's a second degree polynomial. So I have the tie that I need, because if I'm going to have a horizontal asymptote anywhere other than 0, it has to be in a tie in degrees. So it's a second degree and second degree, and the leading coefficients of each of those are 1, so the ratio is 1 to 1, and that's exactly where a horizontal asymptote is. So I should have, in this current form, the x times x minus 4 and x plus 3 times x minus 2, and a rational equation that would satisfy the conditions of this problem. And the second one, there's some context clues here that we're going to use. First of all, I'm going to use, once again like I did before, I'm going to use the zeros of the function. So it looks like there's a 0 at -2, so that's going to be x plus 2. It looks like that is the only 0 that we have in this function. Then I'm going to be looking at these vertical asymptotes again. So I'm just going to speed that process up a little bit. It looks like there's a vertical asymptote here at 1, and it also looks like there's a vertical asymptote here at 3. So that means I can write 2 factors in the denominator. One is an x plus 3, the other one is an x minus 1. I also notice that there's a hole in the graph, so anytime we have a hole in the graph, we have to have the identical factors on the top and the bottom. So that means in the numerator I have an x minus 3, and also in the denominator there's an x minus 3. So I'm using the hole. We had our x-intercepts, we use the vertical asymptotes, and now I'm looking for the location of the horizontal asymptote. Well, in this case, the horizontal asymptote is along this x-axis when y is equal to 0. The horizontal asymptote is only at 0 anytime the degree of the denominator is bigger than the degree of the numerator. So I want to double check the degrees of my numerator and denominator. If I were to multiply all the x's together, that would be an x squared. If I multiplied all of my x's together, we have an x cubed. So that's meeting the requirements of what I know I need. I need to have a degree of the denominator bigger than the numerator, so it forces the end behavior to go towards 0. So in this current form, I should have an equation, a rational equation, that will give us this graph that's shown. So using your x-intercepts, using your vertical asymptotes, and the location of holes, and the location of horizontal asymptotes to help you write the entire equation of your rational expression.